Hey, I'm here today with Ian Kraemer, the founder and executive chairman of a company called New H2O Energy, which has a very innovative potential solution to the energy storage question. Ian, how are you today?
Yeah, I'm very well, David. How are you doing?
Just great, just great. You have a 40-year career, just as I had a 40-year career in oil and gas. You've had a 40-year career in mining.
Yeah, that's
Uh,
correct. I
Tell me about that. Where did you get started and what was your progression?
Sure. I'm obviously Australian, and after I finished high school as a 16-year-old, actually, I went down an underground coal mine and started working as an underground coal miner in
Wow.
Australia. And I did that for about 8 years, and I did external technical courses from a technical college, and gradually worked my way up to mine manager of an underground coal mine. That was pretty well my career in the 1980s. I was involved with carrying bodies out of an underground coal mine disaster when I was young, 22 years old, 23. And I ended up traveling around the world and ended up in New York City, of all places, with a young lady who I got married to. I got into Columbia University in New York and did a couple of mining engineering degrees, and then got a job with a large coal company in Appalachia. And so I spent basically 10 years in the US, 5 at university and 5 working in coal mining in the US. So probably, getting on towards the first 15, 20 years of my life in coal mining. Um, then that company sent me back to Australia, and they had a small gold mining division and a
Ah,
nickel mining division. So I started to cut my teeth in metal mining. Um, and I pretty well uh, left that company a couple of years later and got a job in Australia, working for one of the largest contract mining companies in the world. And my role was to buy underperforming mines, get them running again. I also did technology development and various things. So I did that for 10 years in Australia. And then I was headhunted to be the managing director of a small listed mining exploration company in Australia, which I did for about 10 years. So that's about 30 years so far. Um,
we're
and in
moving on.
Yeah, right. The decades tick by.
Yeah, they do.
But I left that company about eight years ago, and have since founded a couple of mining companies that were focused on the transition to the renewable world. Um, and that's what I've been doing for the last 8 years. And New H2O Energy is one of those.
Well, I mean, and you can see how that career led up to New H2O Energy. You have this concept for using um, already existing coal mines as a storage device for renewable energy. Talk about how that works.
Yeah, I first started to think about that actually in the late 90s when I was at university in New York. And that was around the time that Al Gore was releasing his movie An Inconvenient Truth, and the
Yeah.
entire um, population was starting to think about fossil fuels and global warming and the like. Um, and it seemed obvious to me that if we were going to transition from our reliable coal-fired power to very intermittent solar and wind, that we were going to have a problem.
Yeah.
And so it comes down to storage, obviously. It needs some form of storing the power when it's available and releasing it when it's not, that power is not available. And there's effectively two methods of doing that. There's your traditional batteries, and you're seeing large lithium ion batteries in shipping containers that sit next to solar farms, get charged by the solar, and can release energy. But they have big constraints in that they only really last for an hour or two
Yeah.
before they drain their power, and they're very, if we say they're not very powerful, they don't have the big solid inertia strength that coal or nuclear power plants do. But the other form of storage, which is tried and proven for a century, is hydro dams and pumped hydro. So pumped hydro is effectively a hydro dam like you would find at the Hoover Dam or Niagara Falls, where you've got a spinning turbine driven by that water. But you build a second dam just downstream of that to catch the water that comes through the turbine. And then you use the solar power or the wind power to pump that back up into the other dam.
Yeah.
So effectively, it's a storage device. So that's what pumped hydro is. And tried and proven, very simple technology. You can build them and they'll last for hundreds of years. And if we had those scattered around the country, you could see that would open the floodgates for things like solar and wind, because you could then have around the clock green energy.
Right.
But those facilities have very large roadblocks in front of them. First of all, they're very expensive to build. Billions and billions of dollars to big civil infrastructure dams to create the dams. They take decades to build.
Yeah.
And getting the permits to build them is a huge issue because people rightfully don't want to see more of their rivers and streams dammed. So the permitting side of it's very difficult.
And in fact, we're going the other direction, right? I mean, right now we have this movement to actually remove existing dams that have created solar or hydropower for many decades.
Exactly right. There are a lot of dams that have been removed around the world at the moment to effectively return environmental flows to rivers, salmon spawning and all sorts of different things, all different reasons. They also don't happen to be in the right place. The reason I say the right place is what's happening is we're being forced to shut down our coal-fired power stations. And the coal-fired power stations have all the big high voltage transmission lines radiating out from them.
Right.
And if we have to build new transmission lines, you'll be aware in the United States that getting new transmission lines approved is a very difficult thing, but also they cost a lot of money. So if one could be putting the storage near where those coal-fired power stations are, then you start to add on benefits, economic benefits, time benefits. And it just happens that the coal mines that supplied those power stations for decades and decades are big holes in the ground, effectively big dams. So a bunch of years ago, myself and a number of like-minded colleagues started to think about this and go, well, gee, we're shutting down our coal-fired power stations. We're having to shut down our coal mines that supplied them. They're going to need to be replaced with storage. Guess what? There's the storage right there, right beside the coal mines. In the coal mines, actually. So
in the coal mines,
the evolution of the logic behind it.
So does the concept work only with a surface mining operation, or does it also function with an underground mining operation? And I know often the two are combined with one another, but if you have only an underground mining operation, does your concept fill the need?
Yeah, obviously each set of coal mines that you find is it's unique.
Yeah.
Although they all kind of are the same, but the concept works in any of them. So the basic concept for pumped hydro is that you need vertical head to drop the water.
Yeah.
Okay. And there's massive pumped hydro dams have been built in the last 20 or 30 years with anything down to 60 foot of vertical head. That's not most of them, thousands of feet, 2,000, 3,000 feet. But it's just the balance of the vertical drop versus the size of the pipe, really, to give you the power. And so wherever you can find anything, we like to look for something around 100 to 200 feet at least of vertical drop. But most coal mines, even the surface ones, will have that kind of depth. And then the underground, which extends from the surface, may be 2,000 feet vertical depth. So we can effectively do it in anything, in any surface mine, underground mine, sets of surface and underground mines.
But don't you, when you talk about vertical drop, don't you need a surface area for a reservoir of water that rises while the sun's shining and the wind's blowing, and then overnight, when you want the battery to kick in, doesn't this involve water needing to drop to turn the
Absolutely,
turbine,
it
right?
it does. So
So
the interesting thing is that most coal seams are either flat or inclined,
right,
right?
right.
So what happens is that if this is the surface of the Earth and the coal seam is like that, sorry for the, I hope you can see that,
Yeah.
is that the piece that's near the surface will get extracted by a surface mine.
Yeah.
And then once it gets too deep, then they'll start extracting the coal underground. So the and even if the underground coal seam is flat, it may be 1,000 feet below the surface. So what they'll do is that they'll put decline tunnels and vertical shafts into it to meet it.
Yeah.
But generally, you'll have both. You'll have a surface mine and an underground mine. And even if it's just an underground mine, because of the slope, you can use the upper part of the underground mine as the upper reservoir and the lower part of the mine as the lower reservoir with turbines in between. So it's kind of like you look at any particular mining area and generally you can figure out a way to put a pumped hydro into it.
Right. Yeah, I worked for a company called Burlington Resources in the 90s and aughts, the first decade of the century. And we produced a lot of natural gas out of a Fruitland coal formation in northwest New Mexico. It outcropped near Durango, Colorado, which is right on the border with New Mexico. But 20 miles away, where we were drilling most of our wells, 20, 30 miles away, the coal seam was 3, 4, 5,000 feet deep, and
Exactly.
so it was on an incline. Um, and so, yeah, that all makes a lot of sense to me. And of course, you in these coal formations at where they've been mined, you have pretty much a permanent resource of water, right, already in place because the coal seams themselves are saturated with water. That the pressure from the water is what holds the methane to the coal, right?
Yes, that's exactly right. The coal seams themselves form aquifer basins, and they can, run for thousands of
Yeah,
miles and into the mountains. And when it rains, that water percolates down into the layers of coal and sandstone and shales, and that's basically your aquifer water. It's all nice and clean. Coal is a carbon; it's like a carbon filter.
yeah,
And when we dig a mine into it, then that water, it doesn't rush into it. It sort of flows slowly and fills the void up. And all mining, whether it's metal mining or coal mining, have pumps running all the time to keep the water out so they can mine. And once you stop mining, that water gradually fills the void up again.
yeah,
Um, Obviously, if you have a surface mine when it's raining and snowing and the like, once you've finished mining, they generally fill up full of water. And that's important because our business is about moving water around. The good thing about our business is we're taking older mines that have to be rehabilitated. Sometimes the company might go broke into administration, and instead of then that water not being managed and flowing out with whatever impacts it has,
yeah.
we'll come into the mine, take it over. As part of building our facility, we rehabilitate the mine, and then we are constantly using that water in a closed loop. So we're effectively pumping it up, dropping it down, pumping it up, dropping it down, and managing and controlling everything to do with the water.
So you have a surface reservoir in place, you have an underground reservoir in place, you have the vertical drop already in place, you have transmission already built, all that infrastructure in place because the coal fire power plant is adjacent to the coal mine. What's not to like about this idea?
You tell me.
So what
Yeah,
are the roadblocks? I mean, what do you have to overcome in terms of convincing governments, policymakers that this is a concept whose time has come and they ought to be encouraging it?
I think it's a lot of things in pre-feasibility and feasibility study are about both technical risk and commercial risk.
Yeah,
So obviously, we're not saying that there's no technical risk. What we're doing is it's a non-traditional pumped hydro in that there are coal pillars that are left underground that we want to understand how the water flow in and out will impact on a long-term basis. We want to understand um, what efficiencies and powers we can develop. So there is some technical risk, and my colleagues and I, who are all veteran underground coal miners,
yeah,
are confident that those are dealable with. We deal with those kinds of things every day. Um, then there's the risks around getting access to power transmission grids and buying and selling power. Whenever you come up with a new industry like this, then the regulatory environment may not well be ready for it yet.
yeah, yeah.
So, as you're probably aware, um, there's outfits like FERC and FEMA and others in the US that manage the national grids and the wholesale power markets, but there's also the large corporations um, who operate the power stations and the wholesale and the resale end of business. So part of the feasibility study processes is that we intend to build a smaller demonstration scale one of these and work with those regulatory environments to ensure that um, plugging this into the grid is not going to overly impact the grid, that the regulatory environment, that the laws around it can all be developed accordingly. So there's a bit of um, time delay at the moment with respect to a lot of renewable energy coming into the grid, because a
Right.
lot of renewable energy, like solar and wind, the the power curve, the waveform style of thing that it is, isn't quite right for the grid. The grid needs to be balanced. So yeah, there's work to do with the regulatory agencies, with the wholesaler retailer groups around this. But again, we're confident that all of that can be dealt with.
Isn't that what you're in the United States right now working on is, trying to do some of that upfront work to get a
Yeah,
project underway?
it's been an interesting journey. We even though the idea came to us decades ago, we essentially founded this company in Australia about 5, 6 years ago, and we spent time growing the company, getting seed investment, working with the big coal companies and power companies over there to introduce them to the idea, the benefits of it to them, um, seek demonstration sites, potential funding, doing engineering designs and the like. In Australia, the industry is more constrained and centrally managed than it is in America. There's many less coal mines
Right.
held, major large coal mines held by large international companies. Um, but what we really wanted to do is to not just rely on one demonstration project in one part of the world, but this is a global problem that's being confronted by the Western world essentially. And Australia and the US are both very similar places in that regard. But the US offers a whole other level of access. It offers many, many more coal mines. It offers a much different access to capital. Um, there's of course, the Infrastructure Reduction Fund that has started to um, put out a lot of grant money and capital for this very kind of thing, especially on coal mine sites.
Yeah.
So we took the opportunity a few years ago to found another small subsidiary in the US here in Alabama, because we knew people here and we knew that the topography was right and that the coal mines here were amenable to what we were doing. And what we're looking to do, and we're quite close now, is to have one or two potential demonstration sites in each of Australia and the US, and then come to the market with demonstration projects on both sides of the planet.
Yeah. Yeah. So it's so interesting. Obviously, I mean, the coal mines are where they are. The coal seams are where they are. This is not a magical solution that's going to solve the issue everywhere. But where this infrastructure already exists and these mines already exist and the transmission's already there, golly, this seems like a really attractive way of helping to solve this, what's been a pretty intractable issue for the renewable energy industries. This need for a longer term or a battery kind of solution, storage solution that doesn't have a 3 hour cycle time, which is what we have in Texas right now. And I think all over the country really. And this also has to be a pretty appealing concept to the coal companies themselves, just in terms of extending the useful life of the mines they've already have, and the power plants that they've had to retire. Here you have a concept that can extend the useful life of that infrastructure, right?
It's a really interesting issue you raise. Um, the political divide,
Yeah,
the left and the right, conservatives and progressives, um, on one side just kill coal for no reason. On the other side, climate change isn't happening. How can you breach that divide? I come to this from the perspective of I'm an underground coal miner in my past, and it got to be that that coal miners were almost embarrassed about what they did and wouldn't tell anyone what they did because it was a very
right,
negative thing. And the coal mining companies, the oil and gas companies, the industrial companies of the world, they built this world that we live in, right, from the
right.
industrial era. Those companies, the financial institutions that have supported them and their workers, are the groups of people who can build the new industrial era for us. Like uh, there's no arguing now that we're going into this new industrial phase of going towards renewables. But how can you have a just transition? How can you move forward together without all these arguments and everyone have their cake and eat it too? So the key to this, in my view, is I think most people recognise that you cannot transition within a year. You can't just,
Yeah, I think so. Yeah,
right? You can't, and everyone
I hope
understands.
so anyway.
So you've got to have a transitional pathway, and the world and the Kyoto and Paris climate conventions and that recognise that, and we've got a target of net zero by 2050, which is 25 years away.
Yeah,
Not that far. So how do you manage that, yet not destroy all the companies we have, destroy all the jobs we have, yet also achieve those ends and be able to afford to do it? Well, it's about that 25-year transition. You can map it out. You can say this coal-fired power station life runs out next year, and this one's in 25 years, and this one in 40 years. And you don't want to be knocking them down early and building a replacement, because building the replacement in and of itself creates CO2 emissions.
yeah,
So you're effectively creating CO2 emissions too early that you shouldn't have had to do. So there is actually a plannable pathway to actually keeping coal mines open to manage this correctly. And here's the way you can do this. This is the key. If you have one coal mine that's currently providing coal to be burnt in a power station releasing emissions, and you close that power station, and instead of closing the coal mine, you use those coal mine workers to work in it to retrofit it to a pumped hydro. Now what you've got is a power station, a pumped hydro power station that's providing that power with zero emissions. So you then go and open up a new coal mine, which will become the coal mine for the power station that's still running. And between the two of them, the coal mine and power station that's still running and the new power station in the coal mine, you've halved the overall emissions.
Yeah, yeah.
Double the power at the same original emissions. So you're actually, by keeping the coal mine and coal power station running over here and converting this one to a renewable power station here, you've actually maintained the base load power that you need, so you're not getting brownouts and blackouts by shutting all the power stations, yet you're progressively going to net zero emissions. And you can plan that over the next 20 or 30 years.
Right.
The current coal companies and the current power companies who are earning their money from coal can transition to owning these facilities and earning their money from power, from renewable power.
Well, of course, there you run into the same opposition from the zealots that the oil and gas industry runs into when it talks about carbon capture, because the net effect is you're having the effect of extending the life of an evil fossil fuel facility, and that, of course, I mean, there's so many in this debate on both sides are kind of zealots, for lack of a better term, that just won't harbor any ideas that extend the life of a power source that they truly do consider to be evil. And it's a shame that the debate has kind of degenerated into what really is more than anything else like a religious debate, and that doesn't seem to be a real productive way to go at it to me.
No, I think, look, there's always going to be the far left and far right edge of the argument, rusted on both sides. To me, we live in modern democracies, and if you can bring the vast majority of the people across the line with you, that's what it's about. A lot of that, to a great extent, is that there hasn't been a silver bullet in the past.
Yeah.
That hasn't been a solution. But the solution needs to bring the mining community with it, not just throw them aside, cast them aside. It needs to show that there's, another 30 or 40 years of future, if not more. There are other uses for coal, other uses for oil and natural gas. After all, they're all actually products of decaying living matter, and they have in them all of the products we need to actually increase agricultural production.
Yeah.
There's uses for coal and oil and natural gas other than burning them. Right? There's a future, and this net zero by 2050 is possibly a pathway to allow the ongoing utilisation of these things for the benefit of humankind. And if we destroy those industries in the short term, we effectively cut off our nose to spite our face in the long term.
Yeah.
But yeah, look, you're probably never going to completely convince everyone, but you never can.
No, that's true, and that's been true throughout all of history, and so there's no reason why we should expect the current era to be any different. But this is a really innovative concept. I'm always glad to hear about this kind of innovative thinking taking place, because that's what it's really going to require. The battery companies have been trying to solve this storage problem for quite some time now. We too often talk about this as if it's a brand new concept, and it's really not. And we've seen stories about the miracle battery technology being right around the corner for 30 years or more, and it's still just around the corner. It's obvious to me it's going to take innovative solutions like this one to really crack that nut, and so I really appreciate you taking the time to talk to me about it.
No, thank you, David. It's always good to have a forum that we can talk about these things, and it is about getting the word out. And yeah, I'd just like your viewers to think about us and seek us out on the internet and come talk to us. We'll all put our shoulders to this grindstone together and get
Yeah.
something done.
Well, thanks very much, and best of luck.
Thank you, David.